Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Today, Aliyan and Moeez are here to present our presentation, which is underwater wireless communication. So, we will be studying in this topic in steps. Firstly, introduction, then history, necessity of underwater wireless communication, underwater wireless communication technology, applications, its advantages as well as its disadvantages, and lastly, conclusion and reference. So, as in air, radio waves travels its data digitally, but in underwater wireless communication, there is acoustic wave. So, what is acoustic wave? The signals that are used to carry digital information through an underwater channel are acoustic waves. So let's we talk about the history of underwater wireless communication. The science of acoustic wave begins in 1490 when Leonardo da Vinci stated its principles. In 1867, Isaac Newton wrote his mathematical principles of natural philosophy, which includes the first mathematical treatment of sound in water. In 1877, Lord Rayleigh wrote the theory of sound and established modern acoustic theory. In 1919, the first scientific paper on underwater acoustic was published. Many advances in underwater acoustic were made, which were summarized later in the series of physics of sound in C, published in 1946. After World War II, the development of sonar system was driven largely by the cold water, resulting in advances in the theoretical and practical understanding of underwater acoustic aided by computer-based techniques. So let's talk about necessity of underwater wireless communication. Wide underwater is not feasible as the I have mentioned below. It is temporary experiment and wide underwater communication breaking of wires can happen, and also it is significant, very expensive to develop. Experiment over long distances to cope up with above situation, we require underwater wireless communication. Underwater wireless communication technology, as I have mentioned before, radio wave do not propagate well underwater due to high energy absorption of water. So radio waves also only work in wireless communication in air. Therefore, underwater communication are based on acoustic links characterized by large propagation delay. The signals that are used to carry digital information through an underwater channel are acoustic channel. Acoustic channel have low bandwidth, and also the propagation speed of acoustic signal is only 1500 meter per second. And continuing the last slide, there underwater wireless communication applications are centralized network topology and decentralized network topology. In centralized network topology, there is a hub as base station A and B in the diagram. So base station A and B send messages to its nodes in cell A and B. And in decentralized network topology, decentralized network topology are organized in much more distributed fashion, as shown in the diagram. Each node within the function works independently and has a power to send message to the other node. Moving on, factor influencing acoustic communication. So this is a very important topic in our presentation, and we will talk how the things which affect acoustic communication. There is path loss due to attenuation and geometric spread. Noise, man-made and ambient noise due to hydrodynamics. Also, there is Doppler frequency spread, multipath propagation, high propagation delay. Moving on, what is acoustic modem? So, employ advanced modulation schemes and channel equalization from improved signal to noise ratio. Employ high error detection and error coding scheme which reduces bit error to less than 10 raised to power minus n. And in acoustic modem, these are the devices acoustic parts which is used, which is DC board, analog front board, and DC to DC converter. Now, I would like to call Muzil Islam to talk about how data is transmitted in acoustic modem.
So the data transmission in modem. When no data is being transmitted, the modem stays in sleep mode. It periodically wakes up to receive possible data being transmitted by far end modem. So basically, it waits for the data transmission. If there is data coming from far end modem, then it works on. When the data is to be transmitted, the modem receives data from its link in sleep mode and then switches to transmit mode and transmit the data. Next slide. So there are basically four advanced modems available: UWM 1000, 2000, 3000, and 4000. They all have the same working but different architecture. Underwater acoustic sensor networks. They are the major part of the underwater wireless communication. They are a group of sensors and vehicles deployed underwater and networked via acoustic links performing collaborative tasks. The equipment used are autonomous underwater vehicles, underwater sensors. So the underwater communication architectures. There are two types of architectures used. The first is 2D architecture. As you all can see, there are the sensors linked with underwater sync. So the sensors linked with underwater sync makes up a cluster. Different clusters, as you can see, there are three clusters here, send their data to surface station, and this surface station then send transmit data to the surface sync, satellite, and onshore sync, which further then processes and sends data to the receiver. Next. The second one is 3D architecture. As you have seen before in 2D architecture, there is not major difference in it. The only difference is that the sensors are anchored. Anchored underwater sensors are used in 3D architecture. Next slide. So then comes the application of underwater wireless communication. There are many applications of underwater wireless communication. The major being are autonomous underwater vehicle, pollution monitoring, ocean current monitoring, equipment monitoring and control, seismic monitoring, remote operated vehicle, acoustic navigation technology for multiple AUVs, solar powered AUVs, disaster detection and early warning. And they all together are also used for defense purposes. Then comes the advantages of the underwater wireless communication. This communication can be used to provide early warning of tsunamis generated by undersea earthquakes by using different sensors and then sending data to the data center. It also avoids data spoofing. It avoids privacy leakage, and it also is used for pollution monitoring. The major disadvantages of this system, this communication is that battery power is limited and usually batteries cannot be recharged. Also because solar energy cannot be exploited. The available bandwidth is severely limited. The channel characteristics including long and variable propagation delays. There are multipath and fading problems. And also there are high bit error rate. So finally, to conclude this presentation, as major part of the ocean bottom yet remain unexplored, there is still an immense scope of more research to be carried on. The main objective is to overcome the present limitations and implement advanced technology for oceanographic research. To cope up with the environmental effects on the noise performance of acoustic system to compete with the future challenges like effective transmission of audio and video signal, etc. So finally, we have the references that we use to make our presentation. Thank you.